So take a look at this one here. This says, this is how we can find the surface area. So this is our formula here. This is kind of nice. And we're just going to talk about this formula for a minute. So anyways, let's just think about any function. So I'm just going to draw one. All right, so here's a function down below here. And let's say this is my A here and this is my B. Okay, so now if I'm thinking about surface area, what I'm going to do is I'm just going to rotate this around the x-axis. And then let's say I did that, and look at the picture that we actually end up with here. So then when we're actually rotating around, we kind of create this vase, it kind of looks like. Now again, it's only the red that's being rotated here. So just kind of keep that in mind too. So we're only looking at the red. So if I was to look at this kind of three-dimensionally, if I could, I'd have something like this going on. Then at the bottom, kind of the same way. There'd be like just like a sleeve here. So that's what it actually looked like. And I'd be finding that surface area. Now think about how this works here. So the arc length would be this piece here. That would be my arc length. And this f of x here is going to be how far I am from the origin. So how far up I go, and that's what this f of x is going to represent here. Okay, and this 2 pi is going to be my rotation, because I'm going around in a circle 2 pi. So that's where that all comes in at. So just something to think about where all these components are. That's what's kind of nice about them. We can see where those things kind of come from in these calculations. So that's kind of nice to be able to see all that. So again, the 2 pi is because I'm going around in a circle 2 pi. And then the fx is going to be my distance from the center to the edge. And the arc length is going to be that length I get there. So it all kind of works together that way. So that's what's kind of cool. So anyways, we're just going to do some of these now, these problems. So let's try one. So now for this problem, it says find the surface area obtained by rotating x being 3t squared and y being 2t cubed on the bound 0 to 5 about the y-axis. So the one I showed you just a second ago was about the x-axis. So this one's going to be a little different. So what I'm going to do is I'm just going to graph these parametric equations here. But before I graph, I have to get this in terms of f of x function here. So that's going to change things a little bit here because I need to use my formula here. So I'm going to need an f of x. So I'm going to get those parametrics in terms of an equation of f of x. So that's going to be so then if I look at this equation here and I just divide by 3, I'm going to get t squared equals x over 3. And that's one way to kind of look at what I have here. So I can break this down a little bit over here, but I got a t cubed here. So I may want to square root it. So that's going to be t square root of x over 3. Then I have to take that and sub that into the other one. Oh, that's going to turn out to be really nasty really fast. Once I run into this problem, I realize, wow, this formula probably isn't the best formula for me to use. So that's when I take a step back and say, okay, are there any other formulas I have? So then here it is. So this formula is using the parametric equations instead of trying to turn it into an fx. And that's what we see here. So we see x prime t, y prime t, we see yt. So these are the ideas we're going to use here. Now this one would be used if I was rotating around the x-axis because we see this yt here. So think about the picture earlier. This distance here was my fx, which here would be my yt. So it's my yt distance. This would be my xt in that direction. So that's what we're seeing here. So when I see this yt out here, I'm looking at my distance from the center to the edge of the graph on the y in the y direction. So that's why it's yt. So for our equation, we would have to have for this piece here xt, because then we're thinking about our object rotating this way. So we want to know that x distance. And that's kind of what we're looking at here. What's our x distance away from the center? So that's the idea for us. So that's the only way this changes here. Now this is actually be a really nice formula to use for this one, as opposed to taking this dark path we were thinking about previously. Okay, so let's get started with that. So I have s equals 2 pi, the integral from, where are we going, from 0 to 5. And before we get started with the rest of this, we are going to need an x prime t and a y prime t. So let's just calculate those really quick. So now we can sub everything in. We have those now. And that's going to be my xt. So my xt is going to be 3t squared. And then I have this integral. And then x prime t squared is going to be 6t squared plus 6t squared squared, all square rooted dt. So then I'm going to have this 2 pi here, the integral from 0 to 5 still, and then 3t squared. Now I'm just going to simplify the inside of this. So that's going to be 36t squared, and that's going to be 36t to the 4th. Okay, so 36t squared plus 36t to the 4th dt. So I'm going to use my calculator to compute this one. Could we do it by hand? Yeah, possibly. But I'm good not integrating these. Like I said, most of these ones we come up with, guys, we're not going to be able to integrate them by hand, at least very easily. So a lot of times we'll just turn to our calculator for the computations here. And that's what we're going to do for this one. So this is what I end up with for the answer here. So again, just kind of keep in mind we have 2 different choices that we can pick for formulas. So, and remember here that we also have where we got to think about this being an xt or a yt. And then I just think about it this way. If I'm rotating around the y, I'm wondering my distance this way for my arc length. Because I could have that closer, and if I do, that's going to be a smaller surface area if I rotate it than if I rotated this one. And that's why this xt and yt are so important here. So that's kind of the gist of this problem. And there's our answer. Done.